Most of the examples you will find in the remainder of the course will involve computations with arrays. So a very important topic is how to systematically derive the update to an array. And let's have a look at that now. So as usual, we use a motivating example. And the example that we're going to use adds the entries of array X to the entries of array Y, and we'll assume that both of these arrays have size n. And this will lead to a while loop, and how to systematically derive this while loop will be the topic of a later unit. And what we're now going to do is we're going to focus on the highlighted section here. And if we look at that in isolation, we end up with a precondition that we're going to call Q sub S because it's the precondition for command S, and the postcondition R sub S, which is the postcondition for command S. And what do we have here? Well, if you look at it carefully, the yellow box in the first predicate, in the precondition, says that the first k elements have been updated and that the remainder of the elements have not yet been updated. And the postcondition says that the first k plus 1 elements of the array have been updated and the remainder has not been updated. And the purpose of the game now is to figure out what command S should be. And how do we do that systematically? Well, let's have a look. As usual, we give ourselves some space. So one thing that we notice about the precondition and the postcondition is that it is the element indexed by k that is somehow special. And let's isolate those by splitting the ranges. So in the postcondition, that means that we have to split the range for the first quantifier, the one highlighted in yellow. And what we're doing here is we're splitting off the element indexed by k in y and in x. And similarly, we can do the same thing for the precondition. And there we notice that the element indexed by k is actually part of the second quantifier, the one that says that y is still equal to its original contents. So we isolate it. And if you now compare and contrast the precondition with the postcondition, you find that the quantified expressions are identical. The yellow box is the same as the yellow box, the orange box is the same as the orange box. It is only the term that we have isolated that updates k that's different, and then the range of k is slightly different. We have 0 less than or equal to k less than n in the precondition, and 0 less than or equal to k plus 1 less than or equal to n in the postcondition. But we've seen that before, and we've seen before that 0 less than or equal to k less than n implies 0 less than or equal to k plus 1 less than or equal to n, and therefore that's not going to be an issue. So what do we do? Well, we have noticed that it's the element indexed by k that changes, and it's only array y that can change in value. So we conclude from this that we're going to have to assign some expression to y of k. Okay, we do what we do. We compute the weakest precondition, assigning the expression e to y of k. And notice that because we have already isolated it, that is a matter of replacing y of k by the expression e. And we get this. And now we can take the approach that Maggie prefers, which is to say, oh, here in the weakest precondition we notice that e is equal to y hat of k plus k, x of k. So we can fill that in for how y of k must be updated. But then we notice that y hat of k refers to the original content, and we always have to be cautious with that. So we go searching through the precondition to find out that y of k is equal to y hat of k. So instead of computing with y hat of k, we should compute with y of k, and we get that. And if we then go and take that to be our command S, then we can fill that in, and then the proof of correctness is right here as part of the derivation for the command. So in summary, when deriving an update to an array, isolate what's different between the precondition and the postcondition, and often from the larger context it may be obvious how to isolate that and which element this might be. For example, in this particular example, we knew that we were sweeping through the arrays x and y from beginning to end, and therefore it was probably the entry indexed by k that would have to be updated.